in the last lesson, we started using the map function to loop through our data and map pieces of data to our reusable components. Now, in this lesson, I want to go through map in greater detail and also look at some of the related functions that help us deal with arrays, such as map, filter, reduce, find, and find index. So go ahead and get the starting code sandbox, and then go ahead and fork your own copy. All right, so here I've got an array of numbers up at the top. And what map allows us to do is to loop through the array and create a new array by doing something with each item. So as you saw, the way that we call this is we need to get hold of an array in order to call map on it. And inside this map function, it's going to expect a function. So we're passing a function into another function. Now, the function that we pass in will determine what we actually want to do with each item. So let's say that I wanted to maybe double each of these items. So I could create a function that takes an input x and simply just returns the value of x multiplied by 2. So this is a doubling function, and it's pretty simple. If I pass this function double into my map function, then it's going to loop through my numbers array, and for each of the numbers in there, it's going to put it as the input of this function and output a new array with each item replaced with double the size of the previous one. Let's go ahead and try it out. This method has an output, and that output can be either captured, so let's call it new numbers, and we can go ahead and console log it. So you can see in our console that we're getting the values 6, 112, 4, 96, and 10, each of which are double the size of each of the items in our numbers array. Now, if you think about this, this is not exactly something that we couldn't do before, right? Because we already knew about the for each, and we've been using it to loop through arrays for a long time now in the course. So if we wanted to do this with for each, we could have done it like this. We could have created a new variable called new numbers and set it to an empty array. And then we could have gotten hold of our numbers array and then called for each. And then inside this for each function, it also expects a function, right? So let's go ahead and create another double function, which takes a number x and it gets hold of this new numbers array and pushes a new value, which is going to be x multiplied by 2 into that new numbers array. And then we can pass that function double into this for each loop. So this is how we would do it using the for each rather than using map. So you can see that map is a lot more concise. Now you might be thinking, well, actually, when we've been using for each, we don't actually define a separate function, right? So we could, in fact, make this a lot simpler by putting that function inside the for each and making it anonymous by removing its name. So it would look something like this, a little bit simpler, right? But equally, we could have done the same with our map function. We can also make that a lot simpler if we wanted to by simply putting this function inside the parentheses and then removing its name and turning it anonymous. Whichever way you do it, you'll notice that it's more concise using map because this function itself actually returns an output, which is a new array. So unlike for each, where we have to create a new empty array, and then every time we do something with each item inside the array, we push to the new array. Instead, with map, it just does it all by itself. This is really, really handy in React when we're creating custom components and mapping data to it. Now, another related and also quite a useful function is filter. Let's say that we've still got our numbers array up here. So let's just move it a bit closer. And I wanted to filter on it. Well, as the name suggests, what it does is it's going to create a new array by keeping only the items that return true. What does that mean? Well, let me show you a demo. Let's say that we have our numbers array and I call the filter method. And inside here, again, it expects a function. Let me write it out. Instead of creating a separate function, I'm just going to create an anonymous function inside here. So this filter function is going to look through each of the numbers inside this numbers array. And for each of these numbers, it's going to return only the ones that meet a particular criteria. So we could say something like return num greater than 10. In this case, we're looking through this numbers array here, and we're checking each of the numbers. So we first start with 3, then 56, and for each of these numbers, we're checking to see if they're greater than 10. And if they are, then we're going to add it to a new array, which is going to be the output of this function. So let's create a const called new numbers and set it to equal this, and then we can go ahead and console log it. And you can see we get 56 and 48, the only two numbers that are greater than 10. Now you can of course switch this up, so create an array where the numbers must be less than 10, in which case we get 3, 2, 5. And this is basically a way of adding a filter to your array and providing a condition that you want to check for. And if that condition is met, and then create a new array with those items that actually return true. I find it quite helpful usually thinking about these methods, map, filter, and reduce, in the context of a method that you should already be pretty familiar with, which is the for each. So let's think about how we might do this with a for each loop. So we might create a new numbers array, which is going to be empty. Then let's get hold of our numbers and then call for each on it. And then inside here, we'll add an anonymous function, which will loop through each of the numbers inside here. So we have access to each of the numbers inside our numbers array. And then we're going to check. We're going to say if num is, so we were checking less than 10 up here, less than 10. Well, then in that case, we're going to push this number, which meets this criteria, into our array of new numbers. So new numbers dot push, and we're going to push num in there. Now when we log new numbers, you can see it's still the same, but it obviously took a lot more effort than simply just using the filter function. Now the final one that sort of fits inside this set map filter reduce is the reduce function. So the reduce function works by accumulating a value and doing something to each of the item in an array. So it sounds a little bit confusing as well, but it will be less confusing when we actually see it in action. Let's say that I wanted to add and sum up all of the items in my numbers array. Well, if I wanted to do that with for each, then I would have to say something like numbers dot for each, and then let's create an anonymous function in here. For each number in numbers, we're going to create a new variable, which we'll call new number, and set it to 0. And then inside this loop, we would have to get hold of new number and add the value of the current number in the array. So it might help if I actually rename this current number. What this loop does is it goes through all of the numbers in this array, and for each of the current number that it's looping through, so the first time it'll be 3, then it's going to add that number to our new number. So 0 becomes 3, and then the next time it loops around, this is 3, and it becomes 59, etc., etc., until we end up with the final value. So we can go ahead and log new number, which is equal to 114. This is the roundabout way of doing it. Now, what if we wanted to do it using our reduce function? Well, it's actually a lot simpler. So we could say numbers dot reduce, and then we can pass in a function which takes an accumulator as well as the current number, and this is going to be the equivalent of that previous variable, and then this is going to be the number which is equal to each and every iteration through the array. And then inside the reduce function, I'm going to return the accumulator plus the current number. And if we go ahead and save this to a variable called new number, because we're already console logging it down here, then you can see the result is the same as the previous method using for each. Now, it might help if you actually go ahead and just console log the value of accumulator and current number every time the loop is run in order to understand how this reduce function works. You can see that the first time the loop is run, the accumulator is already set as the first value, and the current number gets set as the second value. The next time it's run, the accumulator has already been added to the current number, so it's now equal to 56. But the current number now moves on to the next item in the array, and so on and so forth until we get to the end of the array and we end up with our total value. So those three functions are probably some of the most useful JavaScript functions that actually exist even before ES6. If you take a look at the MDN developer docs for map, filter, and reduce, which I'll link to in the course resources, you can take a look at how they work and what parameters they take, but also notice how their compatibility is across all browsers. This was introduced way before ES6, and you can safely use this code anywhere on any browser. But the next two that I want to talk about, the find and find index, were actually introduced relatively recently. So what are they useful for? Well, find is a function that's going to help you find the first item that matches in an array. So for example, inside our numbers array, we could go ahead and call numbers.find. And again, it expects a function. So let's loop through all the numbers in our numbers array and then go ahead and find the first value that is greater than 10. So return num greater than 10. What this does, unlike the filter, is it's not going to loop through the entire array. It's going to stop as soon as one of these returns true. If we go ahead and save this to a constant and log it, you can see that it looped through our array, but it stopped as soon as it found the first item that was greater than 10. And find index works in a similar way, but instead of finding the first item, instead what it does is it finds the index of the first item that matches. So in this case, if we change find to find index, you can see it works pretty much the same way, but now we're getting the index of that first number that matches the criteria, which is of course the index 1, because arrays start from 0. So all of these functions are not for you to memorize. It will be really hard to remember all of these, but instead I recommend really understanding what's going on and what the goals are of each of these methods, map, filter, reduce, find, and find index, so that when you actually have a need for something that one of these functions might be able to help you achieve, somewhere in the back of your mind you might have a light bulb go off and think, oh yeah, there was a function somewhere, whether if it was map, filter, reduce, I can't remember, but one of these can probably do what it is that I need. And then go and have a look at the docs and find the function that you actually need, and then quickly look through the demo and the documentation to see what it actually does and how to use it. So as I always stress, memorization is not what we do in the post-Google world. So in order to test your understanding, I've got a challenge for you. Go ahead and comment out any code that you've already got, and feel free to save it, inside this code sandbox for future reference if you want. But you'll notice that I've also included the Emojipedia file that came from our previous code challenge. And what I want you to do is to go ahead and import the Emojipedia constant from our /Emojipedia file. And then you'll remember that the Emojipedia constant is also an array, right? So when we log it, you can see we've got an array of 3 objects. And each of these have a property called meaning, which contains a whole bunch of text. So your goal is to create a new array that just has the meaning text. For example, this one, and this one. But here's the catch. You have to truncate the text so that it only has a maximum of 100 characters. Here's what it would look like if you have completed the challenge successfully. So here's my new array that I've created using some sort of function, and it logs each of these emoji meanings, but it caps them, if you notice, at 100 characters. So they're all equally long. And this is kind of useful a lot of times when we're creating websites where we want the sizes of cards or boxes to be even across our entire page. And we might just do a truncation like what I've got here. As a hint, you will need to use another method which you might have come across ages ago in the JavaScript section, which is called substring. I've linked to the documentation on this method, so have a look at it, have a think about this problem, and see if you can achieve this outcome and complete the challenge. Pause the video now and give it a go. All right, our starting point is 3 objects in an array. So we know that the map function helps us create a new array by doing something with each of the items. And that kind of matches what we want, right? Because in our case, we want to create a new array of meanings, and the doing something is to truncate it to 100 characters. And we're going to do that to each item in this Emojipedia array. Now that we've settled on the map function, let's go ahead and call it. So we'll say emojipedia.map. Now inside this map function, it of course expects a function which is going to give us every single emoji entry. So let's just call it emoji entry. So we've got 3 emoji entries, each are an object. And the first time this loops through it, what do we want to do with the emoji entry? What do we want to do with it? Well, we want to take the emoji entry. So let's just focus on the first object for now. The emoji entry's meaning, so we're going to be tapping into emoji entry.meaning, and we're going to try and use substring to cut it down to 100 characters. Based on this demo, you can see that the substring takes the string and cuts it between the index specified at the first and the second positions. So in this case, 0, 1, so it starts from O and ends at 3, 2, 3. So we end up with Oz printed out. In our case, if we want 100 characters printed, we can simply use the substring method and cut it from 0 to 100. Now that we've got this newly formatted meaning, what are we going to do with it? Well, we're just going to return it. And what this does is it's going to build a new array, which we can save into a constant, new Emojipedia, and it's going to create it from the meanings in our emoji entries from our Emojipedia with only the first 100 characters. So let's go ahead and log this new Emojipedia. And you can see that I've now got this new array and I've cut the meanings all at 100 characters. So they are now equally long. And this is achieved by using our map function, which maps through this Emojipedia array. And for each of the entries, I've gotten hold of the meaning text, and then I've cut it down to the first 100 characters, and then I've returned it to be added to this new array. If you didn't manage to complete this challenge, I recommend heading back to your code and trying to do this yourself from scratch and play around with the code until it makes sense. It's also worth having a quick read of each of these pieces of documentation, which as usual is really high quality and really helps you get even more understanding of each of these functions. Now, in the next lesson, we're going to learn about something that is ES6 specific, and it's going to help us to cut down on the length of our functions even more. And that is the fat arrow, also known as the JavaScript arrow function. For all of that and more, I'll see you there.